Thank you very much.
Thank you.
Real fast.
Can you hear me without the microphone? Yes, okay. So I'm Ramiro Jordan, I work at EC department. What we're going to present here is something very different. I don't know how many of you heard of URBA. URBA is a program by NSF looking for the next best ideas that will have social impact in the next 30 years. So they're challenge people to come up with project that will make a big social impact and will be funded by many organizations. So URBA is funded by NSF, and they invited us to present the concept of peace engineering. In 2018, we organized here with many organizations the first global peace engineering conference to challenge everybody's mindset to start thinking differently to solve problems, global problems. Forget your flag, forget your national anthem, we're all being cooked in the same pot. Climate change, water, etc. So we organized that conference, and in one of the panels, there were scientists from Los Alamos and Sandia. This is November 2018. They said, alarms are beginning to sound. We are going to have a pandemic. December 2019, you all know what happened, COVID. So science does work. So as an outcome of that big meeting, ad hoc, we created the Peace Engineering Consortium. Peace is about sustainability. Peace is analog, complex adaptive systems. Peace engineering is digital. So we can measure, and we want to do AI and all of this so we can predict and minimize conflict. And this will have big impact. Since then, we created a consortium. There's people from all backgrounds, lawyers, bankers, engineers, physicists, psychologists, sociologists, people from all walks. Plus, we know that we have to create new disciplines. So this is the abstract for URBA. So new engineering to allow us to understand, and what we want to do is predict, forecast, minimize risk. We want to avoid negative peace. We want to focus on positive peace, sustainability, good social relations, and all of that. And it has to be across all scales, subatomic to the cosmos. So that's why we have there two important things that you need to know here. Two types of sensors. Physical sensors, this is the high tech, the physics, the engineering, and all of that. Social sensors that we're lacking. We need to work with the social scientists to come up with good service and try to minimize biases. Biases that create harm, that's the ones we need to avoid. We all bring biases right off the bat, but we have to deal with that. So this is what we're proposing. And if you look at there's a dashboard, and there's all the big tech that we need, data storage, data analytics, AI, quantum computer, all of that, and things that we need to build. The important thing is that peace engineers digital. We have to go through digital transformation, come up with metrics, we'll talk a little bit more about, and create what we call interoperable trusted systems that I trust you. I need to understand the language from legal folks, from economists, from medical people. We need to trust each other. So this is very complicated, and this is something that I've been working on this for about almost 34 years at a consortium that I created. So I know we're between food and the posters and parking tickets. Top research goals. Again, 30 years down the line. We don't know what's going to happen. So consortium, since November 2018, we meet every Friday at 9 a.m. Mountain Time. People from all over the world. We started creating this framework. And you can see this complex adaptive system. This is where we're starting, 10 years, 20, 30 years. We're developing engineering tools for peace professionals. Create a robust tech innovation sector. You'll see why this is important. enable hundreds of billions of dollars for peace finance, try to halve the cost of violence in society. And through this direct research, digital transformation, we'll talk more about that. The sensors, the physical and social sensors are very, very important. And of course, integrating all the computing and methods for forecasting. Why now? Last year, we spent $19.1 trillion in wars. And look at all the different conflicts. Look at the US, just the deaths by guns, violence, displaced people, climate. This is the map where we have conflict. That's the bad side. Look at the right side. Never before we had the largest intergenerational transfer of wealth. $84 trillion is going to be transferred within a couple of years. That means we can fund the US government for 13 years with government doing nothing. That is reality. Never before this has occurred. So how do we do that? We need to come up with metrics. We have come up a series of metrics where we can measure what we call quality of life. So there's a convergent research. Yes, engineering and computing is essential, but we need to bring in the social scientists and finance. I never taught me about finance. I can barely balance my checkbook. But the banking industry, insurance industry, there's no ground truth. It's pure speculation. We can measure that now. So human capital, we need to come up with new types of engineers, new type professionals, system thinkers. Yes, we will generate a lot of IP, trustworthy, and what NSF is looking at is creation of new disciplines. So maybe peace engineering will be a new discipline to be created. And of course, financial capital. So we want to enable investments in peace priorities and at all scales, quality of life. So this is the 30-year program, starting again, 10, 20, 30. And these arrows are the interoperable trusted data. This is one metric developed by Stanford on quality of life. And we can measure now the interdependencies of these blocks, similar to a periodic table. Your turn.
Thank you. I forgot what I was going to say. But anyway, so AI is at the core of peace engineering. And I'm going to talk a little bit about what we call the peace ecosystem. So we intend to first educate people in AI, not just AI people, but engineers and scientists and society in general. So the first step is education, and we intend to educate in AI in order to demystify it. And so our approach of explaining AI, it consists of doing it from a sociotechnical standpoint rather than using the usual descriptions of AI that are based on a technological artifact. So we're able to introduce what we call values in AI. Values are the things that are socially acceptable. And this concept is very vague, but it has been defined by the IEEE and by the European Union in view of its introduction in AI. So we want to increase the presence of AI in undergrad programs in all disciplines. I had in 25, maybe more years, a lot of experience, for example, with doctors or physicists, biologists, sociologists. And they don't really get the idea of AI because we haven't come with good ways to explain what is AI, what really is, what are the risks, what is the power of AI, what are the limitations, the present limitations of AI, what are the barriers, and how to use it for the advancement of society. And so I'll talk about context a little later. So Ramiro talked about physical sensors, social sensors, in the context of our peace engineering environment. So at the core of the peace engineering, as I said, is AI, and AI is introducing what we call a dashboard. So this dashboard uses data, and this data can come from technological, physical sensors, but also from what we call social sensors, right? And so what is a social sensor? Well, it might be a survey. It might be something that you don't even notice, right? It might be some AI, some large language model applied to Twitter in order to test what is the opinion of society about a topic, or can be many other things. And so this is very controversial, right? So far, the big companies, they have been doing it without our permission. So we need to do it in a fair way. So we need social sciences, we need philosophy, we need ethics in order to put together such a thing. And of course, we are going to mix our peace ecosystem with finance and justice. Finance is fundamental, also justice, health sciences, and new disciplines that we want to create. But let me talk about this peace ecosystem. So in our view of this consortium, so we established some enabling domains. Security, entrepreneurship, well, here it says, you cannot see it, but it says peace tech. It's peace technology. Peace, it says peace. So we have to correct that. Peace technology, finance, justice, these are the enabling technologies. And in blue, we have the solution domains, from space technology to climate change, which is a thing. So these are our enabling domains and global and solution domains. And transversally, we have ethics, humanities, and social sciences in one side, engineering, science, and technology on the other side. What is in the middle? Well, our dashboard. And so, how do we define peace engineering that Ramiro talked about? But what is a peace engineering project? Which is something that we presented at NSF. It captured the attention of NSF officers. And it's very easy. So we defined a periodic table of quality of life, and this periodic table of quality of life can be constructed from the transformations of the data that we capture with our sensors, and this can be applied to any engineering project. So one engineering project that can be measured from the point of view of the quality of life, and it is intended to improve these metrics, is a peace engineering project. It's as simple as that. And then we need AI to do these measurements. So as Ramiro said, well, we need verifiable trusted data, also verifiable trusted artificial intelligence that is able to measure the risks and the uncertainties, and this is something that we can do. Maybe not with large language models, but LLMs, they're not the end of the story. There's a lot more to come. Then we will need to be able to forecast. We will need to be able to simulate and to model inside each one of the projects that can be defined as peace technology of peace engineering projects.
So how this works. So NSF, we're pitching this. Next, there'll be a workshop, probably in April, in DC, where we're going to invite around 30 to 50 experts from all over to come and brainstorm with us, and these are the visioning events. So with these people, we have to come up with a plan for the next 30 years, and then funding for these projects. This is not UNM. This is a consortium. We've been working on this project for almost 6 years. We meet every Friday at 9 a.m. Mountain Time to discuss, exchange ideas. Lawyers, bankers, and all of that. So these will be the envisioning events, and then we've been working for many years, like I said. We work with ABET. They have embraced peace engineering. This is the consortium I started in 1990. We created the consortium. We have companies behind this. We have former General Breedlove, he was the former commander of NATO, Georgia Tech. You probably, some of you probably met or heard Shawi Abdallah. He was chair of ECE, provost, EVPR of Georgia Tech. He was president of UNM. He's president of the Lebanese American University. He's got a mess in Lebanon. So we're talking to help him create a peace engineering program there. IEEE Education Society has embraced this. They're going global with IEEE Education on Peace Engineering, book, handbook, case studies, conferences, and all of that. So this has come together, and this is just a partial list of institutions. We can't fit more in that. Having said that, so I'm going to stop here because you need to pay your parking ticket. Thank you.
Thanks for a great team over there. Do we want to take one? Let's take one question from the audience, and then
Let
we'll
me say
continue
one more
over
thing.
posters.
We started a peace engineering minor here. Started with 7 students. This semester I have 106. And we have developed a dashboard starting in New Mexico, Albuquerque, the county, the state, measuring water, air quality, health, and gun violence now. Metrics. Thank you.
Questions? There's a question.
I'm going to take one question.
So, you know, the very complex sociotechnical problems of our time, why do you think AI is really going to be instrumental in helping them? I mean, in many cases, it's not engineering problems, it's dealing with many different value systems, with complexities of levels of abstraction and scale, trying to deal with all the interactions. What's the AI play there to really make a difference?
AI is a very powerful tool and it's evolving. But if you saw the list, which I went very fast, there's more computing there, more analytics. It's a lot about cybersecurity. It's about communications. It's about the key here is verifiable, trusted data. What we need to do is combat misinformation and disinformation. So there's a lot behind there. So something that with this that we participate in global standards is, if you look at the trust principles, trust, it means, it has acronyms, that's a starting. We work with international bodies to make sure data is trusted. So this is where the key is. And then you come up with information, all of that. But the core of this, the coin, is the verified trusted data and creating this interoperable trust. And it's, yes, we need help from everybody. I'm an electrical engineer. I'm learning with my lawyers, colleagues, what to do and what not to do. So everybody's playing the game here. This is an open door. We invite you to participate in this. This is not us. This is a whole bunch of people from all over the world. It started here in 2018, but now it's went viral.
Things okay. We'll end there with, I think the key word of trust is a great place to stop. And so, if someone would bring up the lights, I'm going to just say a quick couple of words before we wrap up with the very, very fast lightning talks with the posters. The first thing I want to do is give a round of applause to our last speakers and our all suite of speakers. We had a huge number of people today, so thanks to all of them.